Today's Engine Diagnostics Methods and Techniques class will provide you tools, resources, and a diagnostic process that will point you to the right solutions quickly and efficiently, reducing downtime and building customer confidence. You will also learn about the process for ECU reprogramming and how to avoid contamination when dealing with the different engine fluids. Becoming a master technician requires hands-on experience and diagnostic skills. Our goal today is to help you take several steps down that path.
Intelligent engines require intelligent training. That means you, as a technician, need to stay on top of your game. John Deere has implemented a new systems-based curriculum to ensure you'll do just that. The John Deere Engine Curriculum is a collection of training courses consisting of 4 levels. Level 1 begins with basic diesel engine concepts. Level 2 introduces theory of operation for John Deere engine systems. Level 3 interactively demonstrates advanced diagnostics through live, online VILT sessions. And finally, the Level 4 ILT brings it all together with an in-person experience for you to practice important procedures designed to demonstrate your skills and competencies. To start or build upon your journey, 3 engine technician learning paths are available in John Deere University. These learning paths are a simple and easy way to automatically guide you from your current training status through the systems-based curriculum, honing your skills along the way, and ultimately improving the customer's experience. The available paths are Engine Technician with Aftertreatment, Engine Technician without Aftertreatment, and Marine Engine Technician. Each contain the appropriate courses to properly prepare you to meet the unique needs of your customers based on engine tier and the markets you serve. With the learning path, you and your training coordinator can sign you up for an entire training program with only a few clicks of the mouse and easily track your progress along the way. Once a learning path is assigned, the system will automatically assess your previous training history, give you credit for any technology and procedures you already understand through courses you've already taken, and assign new training modules accordingly. Get started today by searching these keywords in JDU. Sign up, sign in, and boost your skills.
How to create a job in Service Advisor. Select the Jobs tile. Next, select Start New Job. Enter a name to create a job title. This will be useful later when searching for the job. Note, only the name field is required to proceed with creating a job. For better documentation for each job, you can enter the additional information. Work order and work order segment is if your dealership uses a work order system. Description. Providing a description will help technicians when performing diagnostic work on that machine in the future. Select Next. Enter the PIN or model number in the box and select Search. Locate the correct model and enter the Machine Control Unit PIN in the box before selecting Use this model button. Note, a machine control PIN is not required before selecting Use this model, but it's good practice when properly utilizing Service Advisor. Click Finish. The Service Advisor homepage populates with all proper information for the vehicle being worked on. This video will help you to understand how to navigate from a vehicle tech manual to the proper engine CTM. In this example, we'll be using an 8400R tractor model. Start a context with that model in Service Advisor. The Vehicle Tech Manual is found under the Diagnosis and Test section. Within that TM for the tractor, you navigate to DTC 94.04 for low pressure fuel out of range low. This is found by navigating to Group 211 Diagnostic Trouble Codes under ECU. Click on ECU to expand the ECU code section. Scroll to 94.04 and click on the code to see the diagnostic information. The code description says see ECU 94.04 low pressure fuel out of range low in relevant diesel engine CTM. How do you know which engine CTM is relevant to the vehicle you are working on? Power Assist is one great resource that provides the relevant CTM information. Open the app on your phone and scan or enter the engine serial number or the product identification number. This will provide you with all the information about the engine, such as ECU level and software version. The engine CTM number is also provided. Start a context with model 6090 in Service Advisor. In the Manuals tile, select CTM from the menu and select CTM 117719. Within that manual, find the DTC under Section 4 and Group 161. Select the code 94.04 fuel pressure out of range low. You have now found the diagnostic procedure for this code. The engine CTM includes all diagnostic steps for this procedure. If you're working on construction or forestry equipment, the navigation is a little different. With this example, we will start a context with an 872G grader. Select the Manuals tile and select Operation and Test from the menu. Open the Vehicle TM to access the manual. Expand the engine section 9010 and Group 15 for diagnostic information. Newer manuals include additional information to help identify the engine being worked on. A link is provided to the engine CTM. This video will demonstrate how to connect Service Advisor with an electronic data link, also known as an EDL. With 5E tractors, the diagnostic connector is located on the operator station floor as shown. Connect the John Deere controller cable to the diagnostic connector on the tractor harness. Connect the other end of the John Deere controller cable to the electronic data link. Connect USB cable to electronic data link. Connect other end of USB cable to the computer with Service Advisor offline installed. The power indicator on the EDL will light constant green when properly connected to the computer and the tractor. If the power indicator is blinking, this indicates the EDL is only receiving power from the computer and not the tractor. If the power indicator is off, this indicates there's no power available from either the tractor or the computer. If the communication indicator is lit steadily, this means there is heavy communication occurring through the EDL connection. If the indicator is flashing during use, this is considered normal communication. If the communication indicator is off, this shows no communication is happening and can indicate there's an error with the connection. If using Wi-Fi, the light will illuminate once connection is established. If the red error indicator is illuminated steadily, this indicates an internal EDL error. If the indicator is off, this is considered normal operation. With the key on, engine off, start Service Advisor, enter the 4-digit engine model number. With this example, we will use the 3029, and click on the yellow search icon. Enter the vehicle serial number in the PIN, PIN, or the engine serial number box that corresponds to your engine model. Select Start New Job. It is important to start a new job. This will ensure your work will be saved and accessible for future use. Enter the job name. This field is required. You can add optional information if you choose to. Click Next. No additional information is required for this screen. Click Finish. Select the Diagnostics tile. Click on the Connect button to establish a diagnostic connection. If Service Advisor does not connect, see ECU does not communicate with Service Advisor Diagnostic Procedure in Section 4, Group 150. When diagnostic testing is complete, disconnect and replace dust cap on diagnostic connector.
While working on a machine, you may need to replace or donate an engine ECU. This video will provide a few tips to help you with the reprogramming process. First of all, understand what kind of reprogramming you are doing. Service reprogramming, donating an ECU, engine replacement, or replacing an ECU. There are CTM instructions and DTAC solutions to help you with each of these tasks. Before you begin, verify you are using the latest version of Service Advisor software. It is also important to know the ECU level of the ECU you are working on. No matter what type of reprogramming you are doing, communicating with the ECU is essential. You should be aware there is a great DTAC solution to help you connect properly. The solution is number 78175, a tech tip, cannot establish connection between laptop and ECU. Plus, there are two important attachments you should download from this solution: instructions for the Get ECU ID and identification of the 9-pin diagnostic port circuits. The solution also provides instructions for EDL setup and operation, including the version 3 EDL. If you have issues connecting, physically check your connectors. It's critical to have good power and ground at the 9-pin connector and reliable CAN high and CAN low voltages. Remember the basics here. Physically inspect the 9-pin connector for corroded, damaged, or pushed back pins. Use a meter to check the ground, power, CAN high, and CAN low voltages. If everything checks out good at the 9-pin connector, we need to check the rest of the harness to the ECU. If there are interconnects, you must check those. And then check the connector at the ECU. It is very important to check for bent or backed out pins after an ECU replacement. Always be very careful when plugging in the engine ECU harness. Let's talk about reprogramming terminology described in the CTN. I would like to highlight a few terms. This known good ECU that I'm borrowing from another piece of equipment is the donor ECU. This ECU that is believed to have failed on the tractor is the suspect ECU. The term current ECU may apply to either of these. When connected to this ECU, it is the current ECU. But when I'm connected to this ECU, then that one is the current ECU. Finally, I would like to refer you to another DTAC solution that walks you through the entire step-by-step process of donating an ECU to use elsewhere. Take a look at DTAC solution 102501. It's a tech tip. It's the revised donate process for Service Advisor. In addition to the instructions shown in the solution, there is a link to a video that demonstrates the entire process.
Maximum productivity and uptime are a must for our customers' bottom line and are priorities for us here at John Deere. Prior to the Connected Support Initiative, servicing equipment was reactive, possibly requiring extensive diagnostic time to repair or replace components when they failed without having any idea when that might occur. And as we all know, that timing can be critical. John Deere's innovative technology delivers a proactive solution to alert you, our dealer, of machine-specific concerns by analyzing data from the customer's machine against baseline data or collective data from like machines, both regionally and globally. With reactive diagnostics, your resources are put at the forefront of the process. When a customer reports a problem, you must diagnose the issue via many possible sources of information, like tech manuals, bulletins, or DTAC solutions. The length of time required to diagnose an issue could vary based upon complexity and severity, and sometimes requires additional support from a factory DTAC representative. The proactive diagnostic approach puts John Deere resources to work. While your dealer view of data is limited to machines in your area of responsibility, John Deere views the global collection of machine data through a suite of connected support tools. From this, John Deere engineers utilize expert analytics to outline machine-specific health solutions with precise service directives for you. Your technicians arrive at the machine with the prescribed solution and parts in hand, resulting in greater efficiency, decreased diagnostic time, and ultimately increase the customer's uptime.
A great way to understand expert alerts is to look at an example. Take this 850K working on a job site with nothing indicating to the operator that something is wrong. It looks like a normal day. However, the engine oil pressure regulating valve is failing and the oil pressure is starting to degrade. It's not to the point of setting a diagnostic trouble code, but it's lower than it should be. And I think everyone would agree this operating condition could eventually lead to catastrophic engine failure, causing major machine downtime. This is where we come in. As the crawler operates, machine data is sent to John Deere via the JD-Link telematics system. Our team creates machine health algorithms to monitor this data and notify the responsible dealer there's an issue that needs to be resolved before that catastrophic failure happens. In this particular case, oil pressure values for the 850K are compared over time against other 850K crawlers. When the algorithm detects the signature PRV failure in the oil pressure data, an expert alert is automatically triggered. The dealer is then able to plan the repair at a convenient time for the customer and send a technician with the right parts and solution in hand, saving both the dealer and customer time and money. Instead of a major failure costing tens of thousands of dollars, the dealer resolved this issue for about $100 worth of parts, a couple hours of labor, and 0 hours of diagnostic time. John Deere continues to advance our technologies to help dealers by performing diagnostics remotely and automatically. Our engineering experts have years of hands-on experience solving complex engine problems, and our data scientists use the latest tools and methodologies to deliver expert alerts. The ultimate goal is to provide technicians in the field with tailored solutions that keep our customers up and running.